Good morning students. I am Dr.V.Geetha Dhanalakshmi, Assistant Professor, Department of Computer Applications at Bishop Weber College. Today we are going to see data structure and algorithms. This is a core subject in the computer science. So data structure, which is a specialized way of storing and organizing data in a computer. So we can store and retrieve the data in an efficient manner. We have different kinds of data structure which is suited for different kinds of applications. Next is algorithm. Algorithm is a step-by-step procedure to solve the problems. So this is an effective method which is expressed as a finite set of well-defined instructions for calculating a function. Suppose the algorithm produces yes or no answer, then it is called a decision procedure. One that leads to a solution, then that is a computation procedure. Data structure is broadly classified into two types. One is primitive data structure and another one is non-primitive data structure. In the primitive data structure, we have integer, float, character and pointers. These are all used in the programming languages. Next one is non-primitive data structure. In that we have linear and non-linear data structure. Under the non-linear data structure, we have tree and graphs. And in the linear data structure, arrays, linked list, stack and queue. Today we are going to see about the linked list and the basic operations of the linked list. Okay. So linked list is a linear data structure. So that looks like a series of nodes where each node has two parts. One is data and another one is the next pointer. So in arrays we store the elements in a contiguous location, whereas in the linked list we are storing the elements in the non-contiguous location. So that only we are having the pointer which points the next location of the element. Okay. So here we have head and node. Node contains two parts, that is data part and the next pointer. In the data part we are storing the actual information of the linked list, and whereas in the next pointer, that is the part of the node which points to the next node of the linked list. The head is the pointer which refer the first element of the linked list. Suppose the list is empty, then the head points to null or nothing. Okay. So there are three types of linked list. One is singly linked list, another one is doubly linked list and the last one is circular linked list. Singly linked list we have only two parts, that is data and next pointer. So the data stores the information and the pointer stores the next position of the element. Okay. So the next pointer of the last node stores null as it is the last node of the linked list. Here this is the example. So the first node points the head and the last node points the null. Okay. The first node points the head and the last node which is null. So here our linked list is completed. Okay. So next one is doubly linked list. In the singly linked list we had only two parts. Here we have three parts, that is data, next pointer and previous pointer. Okay. So data, as usual the information is stored, and in the next pointer which is stored the next location of the element, whereas in the previous pointer which points to the previous node of the linked list. So in this doubly linked list we can traverse in both the directions, that is both forward as well as backward. Whereas in the singly linked list we can traverse only in one direction, that is the forward direction. Next one is circular linked list. This type of linked list, here the first and the last nodes are also connected to each other. So there is no null at the end. In this diagram you can see this is the, here we have the next pointer. This next pointer points to the first element of the linked list, so that this is called circular linked list. So next is the basic operations what we can perform in the singly linked list, that is insertion, deletion, traverse and search. Insertion we can do it in three ways: insert at the beginning, insert at the end, insert at the specific location. Likewise, in deletion also we can perform it in three ways: delete at the beginning, delete at the end, delete at a specific position. And traverse, we can traverse the whole list and we will display the elements which are in the list. Next is search. In the search, we will determine whether the element is present in the list or not. So first we are going to see about the insertion. So insert the node at the beginning of the list. So actually in this list we have A, B, C, D. So A is the first element. Now I want to insert the element E in the beginning. So what I am doing? I am removing this head pointer, and now the head pointer is moved to E, and again this pointer points to the location of the first element. So now this is the head pointer and this is the next pointer. So this is the algorithm. What we did, we make the first node of the linked list linked to the new node, and remove the head from the original first node of the linked list, and make the new node as the head of the linked list. So just we are adjusting the pointers. Okay. So next is the inserting node at the end of the list. So for this we have to traverse the whole list. Okay. So we have to set the last node's next reference to point to the new node. That is, we are removing the null node. That is, the last node is the null, isn't it? So we are removing the pointer null, and then we are inserting this E. So now after this D, which points to the location of the E, and this points the null. Okay. So this is the inserting the node at the end of the linked list. Next is inserting node as a specific position. Suppose I want to insert this element E in between B and C. So that is a specific position. So now I have to travel. So before the position. So I travel till here. So what I did, I cut this, I remove this pointer, and I made this E here, and I am adjusting this pointers. So now I am inserting the element at a particular position. So next operation is deletion. So deletion at the front. So here this is very simple. What we are doing, we are simply removing the element and we are making the head node to the next element. So this is insertion at the beginning. Next insertion at the end. So for this like insertion, we have to travel to the list. After that, the last element is removed and the null pointer is switched before to the last element. So this is deletion at the end. Next is delete at a given position. So here I want to remove this R6, so which is in the first position, because the index value is 0, 1, 2, 3 like that. So for that also, what we have to check, if the position is in the first node, then we have to update the head point to the next node. So this will effectively remove the node. So this is the delete the linked list at a given position. Next one is, so this is the algorithm, and this is the traversal of singly linked list. So this is also the fundamental operation. We have to traverse the whole list. So here the input is 1, 2, 3, 4, 5. The last pointer is the null pointer. So we have to move one from one to another till the null pointer, and then we displayed the elements which is stored in the linked list. So this is traversal of singly linked list. Next one is we are going to search an element in a linked list. So from the example, we have 20, 12, 15, 33 and 14. These are the elements which is in the list. We have to search whether the element 15 is present in the list or not. So for that, what we have to do? We have to go one from one. First we will check 20 is equal to 15, no. Then we have to move to 12. 12 is equal to 15, no. Again the pointer is incremented, then we move to next place. So here 15 is equal to 15. So I got the answer. So the output is yes, and 15 is present in the given list. See the next example. We have the elements 36, 12, 19, 40, 20 and 81 that is present in the linked list, but the element I want to search is 15. So what I will do? I will do like the same way. I traverse till 81. So next is the null pointer, that is the list is getting to end. So the element 15 is not found. So I got the output as no, the element 15 is not in the linked list. So these are all the some basic operations about the linked list. I hope you all understand this. Thank you.